everybody, I want to show you how to find the frequency using the wavelength. So let's get started. Let's begin with the equation that relates both wavelength and frequency. So we have lambda times nu equals the speed of light. So here lambda on the left side is going to be the wavelength. It's going to be in meters. Next to it, this V looking thing that is nu, that's going to be frequency. And c is the speed of light. So let's go ahead and label that. Now that it's labeled, we see that the speed of light is in meters per second, which means everything on the left has to match that unit. So it ends up being that lambda always has to be in meters and frequency is in per seconds. Another unit for per seconds is hertz, but for this class we'll just stick with per seconds. Now let's try an example. Let's say that we have a lambda, so a wavelength of 650 nanometers, and you want to see what the frequency of this wavelength is. So the first thing that you have to do is you have to convert nanometers into meters. Let's go ahead and do that. And when I put it into the calculator, I get 6.5 times 10 to the negative 7 meters. If you're a little bit rusty on your scientific notation, what this means is this negative right here, that just means you're moving your decimal point to the left and you're moving it 7 times. So it is cumbersome to put in 0.000 and so on, as opposed to this number. So as you see, it's a very small number. Okay, now that we have lambda in meters, we can go ahead and solve for the frequency of this wavelength. So let's go ahead and put it into our equation. Now that I have it in my equation, what I need to solve for is nu, which is frequency. So I'm going to go ahead and divide both sides by 6.5 times 10 to the negative 7 meters. And let's see what we get. Something very important here are the units. If we look at the left side, both of these are going to cancel, so the units and the numbers. But right here on the right, these meters on the numerator is going to cancel with these meters in the denominator, which means we're going to end up with 1 over s, or seconds to the negative 1, so per seconds, which is good because those are the units for frequency. When I put this in the calculator, I get 4.61 times 10 to the 14th power per seconds. And if you had a little bit of trouble putting this in the calculator, let me show you how to do this. On your calculator, for this numerator, you would have put it as 2.9979, and there's a button that has 2 capital E's on it. You may have to press second E, or the calculator may just have 2 capitals E as a button itself. So you go ahead and do that, and the next number is the exponent, which in this case would be 8. And you would do the similar process for the denominator. So we end up with this as our frequency, and that is how you find frequency using the wavelength. Let me know if you have any questions.